Hi all, this is Gopalakrishnan Palanichamy and this is my submission for peer reviewing Coursera's managing machine learning projects. Let's get started. So before getting into the problem, I just want to share some background information that makes me to choose this particular problem and a solution in the form of a machine learning application. So as of now, anyone in the world is kind of using mobile application mobiles, either it may be Android or iOS, and there will be at least some 20 to 30 different mobile application will be installed in every device, and everyone using at least few applications in a given day. So also um, there will be some set of attacks that's happening now and there in the whole part of the world, right? So the user's personal information, the financial data are always vulnerable, and that will be to vulnerable for the security attacks. Even mobile application developers taking all the measures, the security measures to protect their applications as an mobile application developers. From the start of career. Even I'm a project manager right now, but I'm still kind of managing all the mobile application projects. So we ask our developers, or including me, we are taking all the measures to avoid any security attacks. Still, we are kind of some experiencing some attacks that cost millions to lose their personal information as well as their money. And once again, it's easy to identify the vulnerabilities in the static application. The sense the application not yet published in the stores by simply following the guidelines of the application publishing platforms like a Google Play Store, Apple App Store, the Microsoft Xamarin kind of stores. And we have another thing called OWASP. It is a kind of a common consortium that usually updates or usually provides some set of standards to taken care of for enhancing the mobile security. But what's the problem here? See, once the application is published, then the developer can't predict or prevent the security vulnerabilities in the runtime. It will vary from the application to application. In the sense, there will be some different security attacks for the financial application, and there will be some different attacks for the social media applications or something like that. So how can we can solve it, or what will be we are the usual developers is kind of doing today? So finding out the vulnerability in the runtime is still done through reporting by the user, in the sense the application user or some third parties, which is almost out of hands. If a developer says that, sorry, if a end user says that, I was victim of this particular security attack, until that you doesn't know that there is a kind of attack. So until you provide a next update to the application, and the users need to update that application, or else they still are kind of vulnerable to the security attacks. So to be frank, there is no solution readily available to use. Okay. Then before getting into ML solution, we just want to make a quick check. Why can't we do with an non-ML solution? So see, the non-ML solutions also available like SAST. We call it as a static application security testing. In the sense, we will upload a binary file, consider it maybe an APK or AAP for the Android applications, and IPA is something the executable file for the iOS applications. The SAS will try to identify any data system oriented vulnerabilities as per the OWASP standards. It's again the initial level of the application, which is not interacted by the end user. But the solutions don't have any knowledge about the vulnerabilities that may occur during the runtime of the application and the user's device. Whatever we testing here, the SaaS is moreover, given some virtual environment, and it is, it's like the application not yet published. It's kind of in the executable stage, but not kind of install or something. So, what is the proposal then? What we are going to do here? So, we are going to build a dynamic application security tool, Dash. So, we call it Dash here. So, it is moreover building a deep reinforcement learning based model. It's kind of a little bit complex to identify the security vulnerabilities in the mobile application during the runtime of the application. So, okay. So finding the vulnerabilities in the static application is quite easy. As we know that executable file is a static one. It's more over like a zip file. So you can, zip file is nothing but there is a combined or kind of a collection of classes of for the particular application. And we can analyze those, the source code of each and every class of that file and the application. And we can find the vulnerabilities which are very predefined. And, as like I said, we have the benchmarks for like OS standards for the mobile application. So this is will be the typical DL architecture. I'm trying to provide a very simple or kind of high level of architecture. It's much more complex in the real time. So consider the agent here. It's a software agent is the actual kind of a consider as a virtual agent. It will learn. It's the agent in the sense it's moreover like a convolutional neural network or RNN based algorithm. Okay, it's tried. It's we call it as a software agent in the DRL architecture. So the agent usually runs in the environment in the sense mobile application or moreover the application that's run in a particular device. We can call that device as an environment here. So whenever we get into DRL, usually we have the software agent that learns in the environment, moreover the place in the environment, and we will define some set of states, rewards, and action. If the particular state is exactly predicted by the agent, then we will provide some rewards and there will be some actions also. We will call this as in a queue table. Let's explore this in upcoming slides. Before getting into our deep level of idea or our implementation, let's looks like what will be our success, more of the outcome and the output metrics. As one of the output or outcome metrics will be a software agent learned all the vulnerabilities of the application, the runtime, and it will identify the vulnerabilities in a dynamic environment without any further extended training for the other applications. So we will provide some set of applications as a test data or more of the training data, and we will provide an environment where the application is installed. So whenever in particular a test user kind of testing all the application features, we will be listening all the actions that's happened in the application, and we will provide this information back to the software agent, where the software agent will get trained to identify if there is any vulnerability in the runtime. And one of the output metrics will be as a result, we will provide the list of vulnerabilities found in the applications, and we will be providing some recommendation to fix those before publishing into the application market for the end users. In the sense, we will provide this detailed information to the application developer. We are calling him as a user in this environment. So we will provide this, hey, these are the vulnerabilities we have find your application during the runtime. You can fix it here, or else we will list the vulnerabilities. So either they can do in some a certain way to fix those vulnerabilities. So this is the set I think call as environment. Environment is nothing but it's in this solution. Environment is something moreover and simulator. Consider I just taken the Android simulator here. We am using some third party called Jenny Motion. In this environment, the user will install their application like like what you can see. So, consider developing an application called ABC. Then I will install this ABC application in this given environment, and I will start using all the features. Say for let me sign up, log in, and consider this is like an Amazon like an application. So all the products will be listed here. I will add it to the cart. I will make a purchase here. I will provide a submission here, and I will do all the facilities and all the functionalities of the application here. So while doing this thing, our engine, which is in the backside, will listen all the interactions of the user and the application, and it will all the things will be recorded in the sense what are the preferences they are going to store as a part of the application, what kind of a database they are using, and what are the information that is added in the database, if they're creating some files or not. So what will the communication between the application and the API endpoint, what are the information shared between those HTTPS calls or even any other items. So all will be recorded and will be stored there, and we will provide this information to the our software agent with the previous knowledge about the SaaS thing. So in the SaaS, usually we will get some set of vulnerabilities, and the vulnerabilities will be the first level of information to the software agent. So whenever they find the similar item, then it will easily predict that vulnerability. Hey, this is the new vulnerability. Our kind of a goal is not we're not going to stop at the SAST vulnerabilities. Moreover, we will try to identify any vulnerabilities that may happen in the runtime. Say for before login, the user may not provide any other personal identifier information. Say for there is an option called a support team or customer support inside of the application. The initially the form may ask for the username, their phone number, or some kind of a text message to about describe about their problem. Well, while they are providing this information, if the information is properly transferred to the API endpoints in a secure channel, then it will be fine. But if in the case if the application logic is kind of storing such a information in the device, or kind of sending the information without the encryption, this is a kind of vulnerability. Again, this is the, if we do any man in middle attack or any other brute force attacks, so the hackers or the attackers can see all this percent of information. Okay, so let's see what kind of a data we are going to deal with here, and this will be given the input to the our software agent. So moreover, we will start with the mobile application preference. It will be like a key value pair and the database of the application. So in the mobile, usually we use called as SQLite, and that's a different database also can be used. And the files that is created and managed by the application, and the data shared between the application and the API endpoint. So what are the API calls you guys use in the application, and the data provided by the user, which may or may not be the PAS. PAS is nothing but a personal identifying information. And also another input, we will provide the static test reports of the vulnerability. Before getting into DAST, we will do the quick SAST, and we will get the base level of vulnerability, and that will be also transferred to the our software agent learning. They will do, they will take is a first level of input, and further they will deal with the next set of inputs. For the first iteration of this solution, we will be dealing with the fintech applications. So initially, we will take, say, consider we will some 10 to 20 different of fintech applications, and we will try to identify all the vulnerabilities in this application by running that application in the given environment. Okay, and also we will, while dealing the data. One important thing is how we are going to deal with the data, in the sense that actually goes with the privacy. So we must have a strong policies to retrieve, how we are retrieving, using, and storing the data. Say for, if the environment is kind of if the application developer uninstall the application from the environment, whatever the data we just collected or used or retrieved for that application has to be erased. So this is how we will prevent that our information that is shared between the application endpoints, or what are the information that is dealt with application, will be removed. Okay, so let's do a quick technical assessment before getting into the ML structure. As we said, the proposed solution is not a simple solution, like we are not going to classify or a predictor here, but moreover, we are going to build a deep tier reinforcement learning. With we will get some expertise from the feedbacks of our end users, our developers, product owners, and everything. And we will be preparing a Q table to define the rewards and penalties for the action of agent. This Q table is a nothing but a kind of a mapping table that will, the software agent will use this table to define what is their exact state and what they can do the action if they properly find a vulnerability. And we also introduce some rewards as well as the penalty. If the software agent properly predict or correctly predict an vulnerability, then we will reward an agent, we will reward that agent. If it is fails, then we will provide some penalties to that. If the agent receives the penalty, it will go for in a multiple iteration, and it will looks for whatever the problem it had missed to identify the particular vulnerability. Okay, and creating a virtual environment also kind of a critical for our project. Though it's what I said earlier is a Genie motion emulator, and it will, so again, it's a little bit complex for the software agent to play and train, and the Q table will be continuously updated as per our needs. While it's if the software agent keep on learning very quickly, then we need to check out the rewards option. So we have to define our states and action. If it is taking too much time, either we have to increase the rewards or we have to reduce the penalties as a software agent. Okay, and here we will be using a mix of CNN and RN. CNN is nothing but a convolution neural networks, and RN is based DRL model. So as I said, it's not so kind of a simple algorithm as like what we use with a supervised or non-supervised method. And also, to part of the solution, we will create multiple scripts, Python based scripts, to identify any static vulnerabilities. We will introduce some proxy servers that will act or kind of intermediate between the API endpoints and the application. So it can listen to the all the transfers between the applications, and it will listen for the data also. Okay, and this is a common thing usually how we do in the DRL. So initially we will initialize the Q table, and we will observe the current state. And if the software agent properly predict the state, then we will make think of action, what kind of action we need to do, and we will perform the chosen action. Moreover, here will be the identifying the proper vulnerability, and if the vulnerability is finded, then we will reward the software agent with some reward, and after that we will switch to the next step. And by doing so, we will update the queue table also. This will keep on happening in the iterations until we find or we feel that this particular agent identifies maximum number of vulnerabilities, right? And this is will be our high level of a machine learning system. So I'm trying to provide here is a very high level. There is a little bit kind of a very much complicated, but I'm trying to provide as much as simple design here. So initially we will provide an UI web portal, moreover consider a static page. So we will allow the application developer to upload their binary file, either it may be an Android or iOS file. Once they provide this binary file, we will validate that if it is an valid binary or not. If it is done, then we will create the virtual environment. Virtual environment is nothing but the Android simulator, what I shown earlier. Okay, and as a dash engine, so we will have the following components. The main component is the dash TRL model, where the software agent will be present. It will be keep on communicating with the virtual environment to identify that. Among that, we will have some set of scripts to identify some initial level of vulnerability. Say for if the user is storing some personal identifying information as a part of a database or even in files or something, we will do that. And we will also check for any vulnerabilities, that is for the certification pinnings. So say for if I'm pinging to the endpoint called ABC, I just want to make sure if the endpoint has a proper SSL certification. If not, then this is can be also given as a vulnerability, as the hackers can easily listen to the data whatever we are sharing. And we will be having some proxy servers that will be act as intermediate, then listens at kind of like a packet sniffing tool that will records all the network traffic. Even the network traffic, we will identify if there is any vulnerable or kind of a personal identifiable information shared between these SharePoints. So whenever we get some application logs or files and everything, usually we will share it to our we will share it to our data processing unit, data processing engineer. And we are also using another NLP model. Usually it's based on the transformer based model. The only job for that, it we usually identify any PAS that's found in the logs of data. If it is found, then it will get back to the dash engine, and the dash engine will report to the user that hey, these are the vulnerabilities we have found. That okay, this is the very common level of architecture I have given here. Let's move to the next slide. And one more. So consider if the agent is properly done their job, it's identify the maximum number of vulnerabilities, then it's our part to validate the solution. How can we validate? So there is a number of types or the number of methods we can do validate here. So I just taken the very common items usually we use to the validate items here. So either we will validate against the SAST vulnerability reports, so that is a initial level of reports, and we will check with the agent that it is properly identifies. Then we will check for how long it will take to identify such a known vulnerabilities, and we will check for if there's any other new vulnerabilities that is present in the existing data. One of the main advantage or the main thing we are going for the deep reinforcement learning is that it will identify the pattern which is not known at the initial time of the training, or it is not labeled or anywhere. So that's the main reason we are going for that. And the validation solution will be initially we will start with some potential users initially. In the sense, we will use some internal application developer. Consider I'm working in a concern. It has almost some 10 to 20, 12 different ventures. Among them, 7 to 8 them have individual mobile application. So we will ask those mobile application developer to test out their environment by their installing their application into their given environment, and they will do all the operations. And the end of that, our engine will provide a vulnerability report that hey, these are the vulnerabilities we have found in an application. They will compare against the SAST report. If our system can predict vulnerabilities that is more than that, and it can produce a new set of vulnerabilities, if it is producing in a very quick time, then we can say that this will be one of the successful model. And by doing that also, we have to know and need to update the queue table time on time. So our software agent is always updated with the environment out there. So this is the simplest formula usually we do here to update the new state, and what will be the existing old state, and what will be the rewards here. Okay, so And again, the final thing. So by doing all the things, every ML solution little bit have some potential risks also. The one of the main issue will be the data issue. As we are collecting the lot of data from the environment, so we need to be very sure about the managing the data, and the privacy will be an always issue. So we need to be draft some policy about how we handle the data. Say, consider if the user uninstalls the application, if closes the session, then we need to erase all the information, all the data what we have captured while we are doing the testing, right? And one more thing is the bias. As I said initially, we will start with the fintech application. The vulnerabilities, the software agent will be trained in a such a way. So what kind of a vulnerabilities that may happen in the fintech application? Say for if I introduce the social media applications or any other application, it may lose one or two vulnerabilities. That's kind of understandable, and then we can. That's the reason we are keep on updating the Q table. And the one more technical issue usually we will have is that as we are developing the complex model and training with a vast amount of data, the advancement in the ML also need to be adapted time to time, or else usually we will be left behind. That's it. So this is my proposal here. Please review and let me know if there are any other comments. Thank you. Have a nice day then. Bye bye.